Hey everyone, this is Mel. Today let's go through chapter 4, a gallery of graphs. So it's all about graphs, hyperbola, truncus, circle, and some reflection, translation, and the equation of the circle. Okay, let's start from the hyperbola. So hyperbola is in the form like this. So y equal to, for example, k on x, which k is any random constant. If k is greater than 0, then that means you have something look like this. So if k is positive, then the graph will appear in the first and third quadrant. What about k is smaller than 0? So if k is negative, then it's kind of like a reflection along x-axis or along y-axis, which will have graph in the second and fourth quadrant. So for example, this is y equal to -2 on x. Let's look at the dilation of this graph. So if the red one is 1 on x, then what about 2 on x? So that means we're actually, for every x, for example, if x is equal to 1, if we have this function, then we should be able to get y equal to 1. If x is equal to 1, then for this function, we should get y equal to 2. So it's a stretch along the x-axis, so the y value increase. So that's a dilation. And what about truncus? So truncus is like hyperbola, but it appears in the first and second quadrant. So it have form with x squared like this. So when it's squared, then actually means that because everything with the square is greater than or equal to 0, but in this case, it cannot be 0. So the 0 value cannot be taken. So x squared is greater than 0 in this case. So that means the y value, so 1 over something greater than 0, then that means it will also be greater than 0. Okay, so y don't have the negative value, so all is positive value, y only have positive value, and x can take any value except the 0. It cannot take because the x squared is on the denominator, and we cannot have a denominator equal to 0. So let's also look at a dilation. So if the red curve is 1 on x squared, and then what about 1 on 2x squared? So if there is a 2 here. So it's actually like we can write it as half times the original function, 1 on x squared. So if, let's also take x is equal to 1, the original one, we get y is equal to 1. But now, when x is equal to 1, y is equal to half times 1, which is just half. So it's lowering its value. Or in another case, if let's have a new curve, which is y equal to 2 on x squared. And that means we're actually increasing the value of y, and this will be 1, 2. Okay, so x is equal to 1, then we have y is equal to 2. Okay? And that's truncus. What about circle? So if we have a circle with a center at 0, 0, then the value of the intersection of the x and y axis will be 1 and -1. So the radius is 1. because the r square over here is 1. So we have a general formula. X squared plus y squared is equal to r squared, and r squared is equal to 1, which means r is equal to 1, because our radius must be positive, so r cannot be negative 1. Okay, it's this red circle over here. Then what about the blue one? If we have r squared is equal to 4, that means r is equal to 2. Then that will be just a bigger circle with a bigger radius of 2. Okay. What about square root function? So we know under a square root, x must be greater than and equal to 0. So the y corresponding value will also be greater than and equal to 0. Okay. And this is a red line over here. And if we put a 2 in front of the x, then let's see. If x is equal to 1, we also take x is equal to 1. Then originally, the red one should be square root of 1, which is 1. So 1, 1. Then what about the blue one? So the blue one have y equal to square root of 2, which is 1.4 something, which is larger than 1, this point. And the yellow curve, so 1 on square root 2. And y, 1 divided by 1.4, which is smaller than 1. And that's it. So if we divide something in the square root, then it will get a lower value. If we multiply an integer, a positive integer, like 2 or 3, it will scale up. So it will become square root 2 or square root 3 for x is equal to 1. So that's also a dilation from the x-axis. Okay, let's talk about reflection. So reflection in the axis. We have y equal to negative 2 on x, which is reflected from y is equal to 2 on x. So reflection in x-axis makes this curve come down to the red one, and this curve goes up to the red one. So it looks like this. Okay, and for the truncus, we usually have this. So this can be y equal to 3 on x squared. If we take the negative, so we reflect along the x-axis, then everything is flipped downwards. So that's what it becomes. And about this square root, so square root of x is in the first quadrant, which you can take the 0, 0 value. If it's reflected in the x-axis, then we'll have a negative sign in front, which it goes down to the fourth quadrant. If we have a negative sign inside the square root, inside the root, then it will be flipped along the y-axis. Or you can think of it like this, because we know under the square root, this thing must be, so let's say, for example, a. So this a must be greater than and equal to 0. So if we have a negative x under this root, under this square root, then the negative x must be greater than or equal to 0, which means x is smaller than and equal to 0, which is exactly along the negative x-axis. Translation of graph. So translation is without changing the shape, but moving the shape. How do we get this from the graph, original graph, 1 on x? So for 1 on x, we know it's in the first and third quadrant. So for this graph, we have asymptotes. The horizontal is y equal to 0, and vertical is x is equal to 0. So note that the cross of the asymptotes is 0, 0. And if we want to move the graph to the right, and that means our vertical asymptote becomes x is equal to 1. So we cannot take the value of x is equal to 1. And that actually means for the denominator, we have x minus 1. Because we cannot take the denominator to be 1. And that means x minus 1 cannot be 0. And x cannot be 1. So when we move to the graph to the right, it actually means a minus for the x-axis. So if we move to the left instead, then actually means plus for the x value. So instead, we move to the left, it will become x equal to negative 1. So x cannot take the value of negative 1, which means we have to do a x plus 1. And because x plus 1 cannot be 0, x cannot be negative 1. So this is one way you can think of it. Think of the translations, because this hyperbola have a very important property, is that the asymptote actually relates with the function. So if you have an asymptote of x is equal to 1, and that means in the function, beside the x, you have a x minus 1. So what about translation on the y-axis? So it actually means moving the graph up or moving the graph down. So if you want the graph to be up, then we do a plus. If we want the graph to move down, then we do a minus. And the asymptote will also change, and it will be the same as what you put on the function. So asymptote is 2, then you do a plus 2. Okay, now about circle. So circle, we also have a very important point, which is the center. So how did we get from this graph, which is also a radius of 2, to this graph, this red curve? So it's clearly that we move the center and every point on the curve, on the circle, to the right by 2 units, because it should be 0 and 0, and then it moved to 2 and 2. And similar, for the x over here, if we want to move to the right, then we do a minus 2. If we want to move up, then we also do a minus 2, because under the square, we want it to be 0 to satisfy the center point. So although this center is not on the function, if the thing under the square of x and the thing under the square of y is 0, for example over here, if we take x minus 2 is equal to 0 and y minus 2 is equal to 0, then we get the center point, which is x equal to y equal to 2. And it's exactly the center. Okay? And a very general thing, if you do not know what's the right graph or what's the right function when doing translation and reflection, you can easily take a point. For example, if we take in this graph, let's say x is equal to 2. Then in the normal graph, we will get when x is equal to 2, y is equal to half. And you can plot the graph. So how did this point, 1 and half, move to this point when x is equal to 2, y is equal to 1 plus 2 is 3. So 2 and 3. So you can actually see how the whole graph being translated to the right and up. Okay, equations for circle with center h and k and radius r. So how do we define a circle? It's defined by the radius or the r square and also the center, 2, 2 here. So what we minus to the x and what we minus to the y, that makes our center, h, k. Or this alternative form, which you just expand everything under the square, and it becomes something like this. And the c is this part. So other constant without x and y. Okay. That's it for today. Thanks for listening.